Hello and welcome to Maths with Jacob. This lesson will focus on ratio and rates. Ratio. A ratio compares quantities of the same kind. Also, a ratio has a specific order. For example, the ratio of Tom's marbles to Sam's marbles is 3:7. Since Tom is mentioned first, the 3 represents his portion. Since Sam is mentioned second, the 7 represents his portion. Hence, we know that Tom has less marbles than Sam. We can see how order is important. Finally, we don't know the exact number of marbles owned by each person. Another example. There are cars, trucks and bikes in a car park. The ratio of cars to trucks to bikes is 7:3:2. So cars is to trucks is to bikes equals 7:3:2. So the important thing is this. The cars represents the 7 parts. It doesn't mean there are 7 cars. The trucks represents 3 parts and the bikes represent 2 parts. We'll see all this later in the next slide when we do some examples. We'll see actually what this means and how to use it. We can see then from this information there are more cars than either trucks or bikes because the 7 represents the cars, but the trucks is only 3 and the bikes is 2, so there are more cars than either trucks or bikes. There are more trucks than bikes, because the trucks has 3 parts and the bikes only has 2. Bikes has the lowest representation. We can see that, because that's only 2. We don't know how many of each mode of transport is present. Simplifying ratios. Simplifying ratios is similar to simplifying fractions. For example, if you have a ratio of 15:9 and we want to simplify it, this is what happens. We can see that 3 is the highest number that divides into both 15 and 9. So we divide each of these numbers by 3. 15 divided by 3 gives us 5. 9 divided by 3 gives us 3. So 15:9 is exactly the same as 5:3, but that has been simplified. Let's look at rate. Rate compares quantities of a different kind. Now you've all heard of this. Let's look at these simple examples. A car travels at 70 kilometers per hour. Now, it says quantities of a different kind. This first example is representing distance and time. Okay, so they're different measurements. That's why it's a rate. Sugar costs 60 cents per kilogram. Here we're looking at money, or a cost, and here we're looking at mass. That's why it's a rate, because they're quantities of a different kind. Let's do some typical examples now. Firstly, using ratios. In a class of 32, they could be students, there are 24 boys and 18 girls. What is the ratio of boys to girls? So the answer, 24:18. The answer is 4:3. How did we get that? We divided the 24 and the 18 by 6. Because 6 is the highest number that divides into 24 and into 18 evenly. 24 divided by 6 gives you 4. 18 divided by 6 gives you 3. So the answer is 4:3. Next question. Divide 48 in the ratio 3:5. Now, let's look at the 2 parts. 3 parts plus 5 parts. There are 8 parts altogether. Now the trick is to find out what 1 part represents. So if we take the 48 and we know that it's divided into 8 parts, okay, we just go 1 part is 48 divided by 8. If the 8 parts represent 48, then 1 part is 48 divided by 8, and that equals 6. So 1 part is 6. So the 3 parts must be 3 times 6, and the 5 parts must be 5 times 6. So the answer is 18 and 30. And if you add 18 and 30, you get 48, so we know the answer is correct. Here's a question on rate, a couple of questions. Tom has 160 trees spread over 4 hectares. What is the average number of trees per hectare? The answer, if we divide 160 divided by 4, because it's 160 trees per 4 hectares, we get 40. So the answer is 40 trees per hectare. So it's a number of trees, and that's an area. That's why it's a rate. The next question, John paid $35 for 5 books. What is the average price per book? If we go $35 and we divide that by 5, that's the number of books, we get 7. So the answer is $7 per book. So that's an amount of money, and that's the number of books, and that's why it's called a rate. So this little video has introduced some questions on ratio and rate, and it's explained the difference between the two.